Let's look at the R commands in the program. The first command set par, so this sets the parameter of the page layouts. We are going to put 4 figures in one page and put them into 2 rows and 2 columns. First, we generate data and store in X. The data comes from binomial distribution. We are going to generate 10 of them and store this in X. Then we draw the histogram of those 10 data points. We use the bricks to set where the interval breaks are, so we are not going to use default values. We set them at 0.05, 1.5, 2.5, such things. So what that means is the middle of the intervals are at the integer values, 0, 1, 2s. The main basically gives us the title, so this line here will be the title, which will be printed on top of the histogram. Next, we use the points command to overlay the theoretical density functions over the histogram. So you see the density function of the binomial distributions. We draw this, so this is from the theoretical probability distribution. We use type H, which would draw those values as vertical lines, so just show a few sticks, so you can compare with the histogram. This will give us the first figure. Then we use similar command to produce the second, third, and fourth figures. Now we put all R commands into one R script and save it in a file. To execute all those commands, if you are in RStudio, like what I am here, you can just use this little key here, say run, and this will execute this whole script. Alternatively, you can also go to the R console, which is what you would do if you don't have the RStudio, and enter this command here, say source, and give the file name. This will also execute the whole R script. And just make sure this file is actually in your working directories. Otherwise, you'll need a longer line here and tell where the location of the file is. So if we execute the script, you can see, as we already explained, this will produce 4 figures in one page in 2 rows and 2 columns. Each figure shows the histogram and then overlaid with the theoretical distribution represented by those red lines. What we observe is that when n sample size increases from 10 to 100 to 1000, 10,000, the histogram and the theoretical distribution get closer and closer.